Well, I hope you can see it. I'm trying to show you cracks. As you look at these cracks here, you'll notice that it's a crack. But on this side, the tension that was created in the pad rotating down resulted in this crack pattern. The control joint is this joint they put down about 3/8 of an inch, half an inch, and that's where it was the weak dissection of the material at that point created by the control joint. And then you see the fracture of it. Proof further that for you guys out there, you see where it was at one time. The pad was up there at that step. The water pile there came underneath of it, whatever way, coming through, rotating over the sill here. This is acting like a gutter, or got back there, doesn't matter. The soil settled. This concrete had a cantilever at that point above the soil, so I'm using two dimensions here, one dimension for you guys. And it's settled. The soil's down here, so at one point it was on top. As the soil settled, the profile of it looked sort of like that at that point, cantilevering, soil down here, not being supported. So then, not gravity, but not being supported. This in a cantilevered action could take it without any fractures in here. It could rotate over. It was supported back here, not by rebar, but by the concrete in tension, bonding the two sides. It bound it for as long as it could before separating the stresses. But not only here though, there was some bond at the wall here. So it was, see the bond there? So there was 2 points of connections. Over here, more so surface there, and over there probably a lot less. If you go down, it's probably tapered. And let's see if I can find that. Yeah, as you can see, I don't know if you can tell, but it's tapered back. That's the way this fails here at the steps. And a diagonal of 45, the stresses trying to support from the step above, hold it like a drop slab or detail. Can't hold it, no rebar holding it this capacity, drops down. So look at that as that drop slab detail, the transition up. But it's a solid floor. But just try to visualize it multiple ways. If rebar was down and over, that would transfer it back to this slab here. And even with the, and then you would bring rebar over to here. Too much work, but it should have been done because water piles here. So this was avoidable if they would have respected water piles there. This stress caused the rotation there. We ultimately get stresses back to here, which did not fracture this joint. This joint was not cut deep enough, or it was more concrete there, which allowed it to still rotate it way out to there. That's where it created the in-plane stress. In-plane meaning, my definition of it, I mean, look at it parallel to this one, 90 degrees parallel, perpendicular to the sidewalk, or this 90 here. So the forces are trying to pull down, and there's our resolution right there. Over here, you see the same thing. Could you guys tell me about this one? I won't do a video on this. I'll just hold it for you, because you already should know what we're looking at from what I just showed you. There's a reveal, and this is not a control joint. This is an expansion joint. It's fully opened with probably maybe there's asphalt in there back then. All right, end of story. Hopefully you enjoy it. And that's the rest of the news.